All right. It's 5:59. Woke up a little bit late. Well, I woke up on time, but kind of just stayed in bed for 30 minutes. Okay. So what I'm going to be doing today is preparing for my ML conference. Um, it's at 9 p.m. I should get the link out. Okay. So it's 4:46 p.m. in BST, which translates to around like 6 p.m. BST. Around like 6:19, 6:16, 9:16. What the heck am I saying? So around like 9 p.m. So gotta get this presentation finalized before then. Honestly, I have no idea how to like present to a conference, so I'm just gonna be making this shit up as I go. Let's look at like presentation. So around like 12 minutes for the presentation and 3 minutes for questions. How much time do I have? 45 to 5. That's it. Yeah, it's around like 15 minutes. One slide per minute of speaking time. So I should have around like, yeah, 10 minutes, 10 slides. Okay, cool. I don't think I should include this. No more than 12 lines of text. and use my paper as a reference. Just gonna have this on the second monitor. So it's um, it's the current way to solve this problem. Have employees sort trash out. How do I improve this slide? What am I thinking? So I'll say something like, I'll start off with, oh shoot, I have no idea how to, yeah, I want to be like, good afternoon, ladies and gentlemen. My name is Harshith, and I'll be presenting um, the paper titled Classification of Recyclable Waste and Generated in Indian Households on behalf of uh, my fellow co-authors. And I'll say, so I think for introduction, start up talking about research. Let's see, what are the guidelines for introductions for oral papers? In addition to the body of the talk, present an introduction or summary, and a summary or conclusion. Um, yeah, but like, does the presentation, I mean, does the introduction have to be relevant to the paper? Why did you do it? Okay. State the major conclusions up front. Okay, oh, interesting. So, research consisted of classifying single images which contain recyclable items into 5 distinct categories: plastic, paper, metal, glass, and cardboard. With a custom dataset containing images of recyclable category. Each recyclable category. Okay. And then I go into the custom dataset. I'll put this here actually. State major conclusions up front. So I guess this is where we're supposed to do that. How am I supposed to do that? guess instead of what is the consequence, I'm going to say what is our solution. I'm going to remove this fact. Have this come after that. There we go. Have employees sort out trash. No, employees sort out trash. Then cheaper for the waste management companies to take options like landfill and incineration. Okay, so I guess my main point here is I want to start with what is the problem of 2.5 million 2.5 thousand million metric tons of plastic produced, only 9% is recycled, which is a crazy low amount. And then I'm going to say something like recyclable materials often get mixed with non reusable garbage, which essentially doesn't allow the recyclable, essentially contaminates the recyclable material, which doesn't allow it to be reusable or recycled. All recyclable items have to be washed and washed before being recycled. So what is the current method? In huge automation factories, employees usually sort out trash by segregating them into different sections, into different categories through which the materials could be recycled based on their materialistic properties. However, it's expensive to, I guess, maintain a factory like this with human workers and hire employees to do this. So what most people do is it's cheaper to just take options like landfilling or incineration, where you don't have to, I guess, mind for cause sorting out the trash. So what exactly is our solution? Okay, now I have to talk about my research here. Automation is not popular in recycling factories due to the lack of accuracy in which the robot arms operate. Like humans, they often fail. Usually robots don't have adaptive intuition. Assertions to give automated robots the vision of to segregate different types of trash. It's also the ability to, I guess, detect materials from vision from camera feed. Improve improve the classification model to suit items from Indian households. I kind of want to give like an introduction, something like when I first moved to India a few years ago, I was appalled by the amount of trash that was being burned on the roadsides. And I knew something had to be done um, about this. And now more than ever, plastic has been affecting the environment and adding to global warming. And one of the main methods of disposing trash or recyclable items in India is the process of incinerating it, which essentially pollutes the environment by releasing carcinogenic materials into the air. So something like that. So why exactly should we solve this problem? Of the 2,000 metric tons million metric tons of plastic produced, only 9% is recycled. And that number of production for recycled plastic materials is increasing rapidly. Recyclable materials often gets mixed up with non-reusable garbage. So yeah, that contaminates the recyclable items, which doesn't allow it to be recycled anymore. The current method to recycle materials is have employees sort out the trash but it's essentially cheaper for waste management companies to just take options like landfill or incineration where they don't have to deal with the classification. They could just dump it into a landfill or they could mass burn it. What is our solution is to give automated robots the vision to segregate different types of trash, because one of the essential problems with having automated robots just do the task of segregation is the fact that they aren't okay, this size has to be +1. They aren't as efficient or accurate as humans. So by trying to improve the inference time and accuracy, we also, in addition to improving the accuracy, trying to improve the accuracy and inference time, we tried to improve the classification model to suit items in the Indian households for better classification of local items. And here's animation of human segregation to automated robots. And I guess the main point here is to keep in mind the fact that when we mention automated robots, it doesn't have to be exactly robots in recycling factories. It could be in any stage of the recycling process where it could also be at the consumer level. Our goal is essentially to provide an inference mechanism for these robots to work and try to get the industry to, I guess, create these robots. So our research consisted of classifying single images, which contain recyclable items into 5 distinct categories: paper, plastic, metal, glass, and cardboard. In order to accomplish this, we built a custom data set containing all the recyclable items of the recyclable categories and utilize a deep learning model to solve the classification problem. I think I should talk about like what the deep learning model is. Check the paper. Scalable learning. So with the model, recyclable items found in India, the capital I. We have created our own 500 images dataset. It's being updated regularly and adding more images. Wooden frame. Okay, I gotta remove this. This dataset is combined with larger, more general images. Yeah, remove this. I want kind of some spacing, but that seems too much. $500 images? I thought we had something like 1,000. Let me double check. Yeah, I think we did end up with 1,000. Okay, the stream is running long. Good design is good prepared. UI design. So this is the breakdown of the ResNet architecture into 4 different blocks. We have the input block, conf block, identity, and output. And this output layer is later fed into an SVM model separately. So basically the trained layers here are then fed into SVM, where SVM uses that for classification. I need to learn how to present this slide because this is pretty much the basis of our research here. So finally, implementation. All right, so convolution layers, and then feed that into a feature vector into the multi-class SVM, and then that basically produces the 5 different categories. And I need to include a slide for results. And let me throw down this image here. Anaheim. Let me just make that the standard. Or should I not? I don't know, maybe. Okay, let's just keep it at that then. What was it? Lato. Mm -mm -mm -mm. 0.2 is a pretty big loss. Because I should talk about like conclusion. Oh. Okay, I'm just gonna end it here. This is already overboard. It's like 40 minutes into it. Alright, I'll be back tomorrow to continue reading Paper a Week. Okay, that's it for today.